Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.3, Problem 4. This is Section 2.3, Problem 4. It says write the fraction in simplest form, and we have 36 over 63. So you want to find the largest value you can that will divide into both those numbers evenly. So as you start, they're not both even. I can't start with a 2. So next we could try a 3. And the trick with a 3 is to add the digits together and see if 3 divides into the result. So the 36, if I add those digits, 3 plus 6 equals 9. 3 divides into 9 evenly, so it'll divide into 36. Now 6 plus 3 for the 63 is actually also 9. And again, 3 divides into 9 evenly. It'll divide into 63 evenly. So I can divide 3 into both evenly. Now I happen to recognize that I can actually divide 9 into both evenly. Let's say I don't realize that. 9 is a better choice. But if you don't realize that, go with anything. And if you're making progress, you'll eventually get to the end. So 3 goes into 36 12 times, because 3 times 12 is 36. 3 goes into 63 21 times, because 3 times 21 is 63. And I can see that the answer is 21, but if you don't, just take a minute and do the division. So 3 goes into 6 twice. 2 times 3 is 6. If you subtract, it goes in evenly. Bring down the next digit. 3 goes into 3 once. 1 times 3 is 3 again. It goes in evenly. And this is 21. So now, as I look at this, 12 over 21, is that as far as it goes, or can I reduce some more? I can reduce some more. 3 still goes into both of those evenly. And again, you can add the digits. 1 plus 2 is 3. 3 goes into 3. 3 will go into 12. These numbers are starting to get small enough I can look at it and see. 3 goes into 12 4 times. 3 goes into 21 7 times. And now 4 over 7 is as small as it will go. Now again, I mentioned that I knew 9 would work. So if you happen to see the 9, 9 goes into 36 4 times, 9 goes into 63 7 times. You'd get the same result in one step instead of 2. But if you don't see it right away, 2 steps is okay.